Hi everyone, I'm Abhishek Paudel. Welcome back to my channel. Today I'm going to solve a problem from hydrostatic force on curved surface. Here you can see a sluice gate which is holding water to a height 6 meter and it acting like a spillway. When there is much quantity of water, it acts like a spillway and it rotates about this pivot O. It goes up and the water will spill out from this point, okay? It works like this, but the question is asking you to find out the net hydrostatic force and how it acts. So that's why I'm going to find out the force acting on this curved surface A, B, C. Okay, for that I need to find out the horizontal force and vertical force in this curved surface. So for that, let's find out the horizontal force first. So horizontal force, okay, the horizontal force is E of H is equal to gamma A x bar. Here you know that its area is a projected area. While calculating the horizontal force on the curved surface, we need to take the projected area in the vertical plane. So that's why let's project the area in the vertical plane. So we have got the contact area from this point A to point C. There is water is contacting on the surface A, B, C. So that's why from the extremity of the curve up to where the water is in contact, I am going to draw a line and projecting this point to the vertical plane, that is this one is C, okay. So and you know this one is a vertical line and this is A and this is C. Here this is a projected in vertical plane and the if the question does not give you the width of the gate or any shape, you need to take the unit width. So that's why I'm taking the 1 meter width of this radial gate. So okay, how much is this one? This is given here. This is 6 meter. The depth of water is given here 6 meter. So in the area is gonna be here. The area is gonna be 6 into 1. That is 6 meter square. The area is 6 meter square, and what is the x bar? The definition of the x bar is that x bar is the vertical distance from the free surface to the centroid of the projected area, So we are taking the projected area in case of horizontal force. That's why the x bar is here. The x bar is the vertical distance from the free surface to the centroid of the projected area. That is 3 meter. Okay, 6 by 2. 6 by 2, that is going to be 3 meter. So finally I have got, gamma is how much? The gamma is 9.81 kilonewton per meter cube. So I have got the horizontal force, that is E of H is equal to 9.81 into 6 into 3. That is going to be how much? The horizontal force acting on the surface is 176.58 kilonewton. This is acting in this direction, right side, okay. The force is acting in this direction, that is 176.58 kilonewton is acting on the right side. So okay, let's go to find out the vertical force acting on this curved surface ABC. We have calculated the horizontal force by projecting the curved surface in the vertical plane. So we have got the 176.58 kilonewton, and finally, okay, let's go to find out the vertical force in this curved surface. So how to calculate the vertical force? Okay, the vertical force is calculated by extending the extremity of the curve up to where the water is in contact to the surface of the liquid, okay. So now let's first find out the extremity of the curve up to where the liquid is in contact. The liquid is in contact up to this point A and to this point C. This A and C is the extremity of the curve. Okay, let's extend the vertical line toward this surface. Here you can see a surface up to this point here. So I'm going to extend this from this point A to the surface, okay. So you get the enclosed part like this, the enclosed lamina, that is A, B, C, and let's say this one is M. So you get the point C here. If you extend the line extend a vertical line from this point A to the surface, you are going to meet at point C. Okay. So now let's extend from C to the surface, but the surface lies in this line, so that's why no need to extend up. So the C meets at this point. Okay. So we have to take the enclosed shaded portion. Okay. This one is a portion which is a shaded part, enclosed part. We can calculate the vertical force by directly by extending the curve, extending the line from this extremity of the curve to the surface. You could have also done by extending the line from this B to the surface, but directly the resultant will come like this. So that's why you can use this direct concept to solve this problem. So we need to find out the area of this shaded portion, and then area into width will give you the volume of this shaded portion up to the water is deflected in this portion, displaced in this portion. So this is going to be responsible for the vertical force acting on the curved surface. So here you can see there is no liquid in the shaded portion because the liquid lies in the left side. So that's, you can say that this is acting vertically upward. The liquid is the vertical force is acting upward in this case. So that's why we need to find out the vertical force by using a formula, that is FB is equal to gamma into volume shaded or enclosed, you can say. Shaded or enclosed. Okay. So volume shaded is found out by gamma into area shaded into width. Okay. Area shaded into width. That is gamma is 9.81 and area shaded is the area of the lamina CBAM. Okay. Area of the lamina CBAM. That is the area of a lamina. You need to calculate the area of this lamina into width is 1 meter. Which is not given here. You have to take the width 1 meter if it is not given. So let's mark this as a equation number 1, and let's go to find out the area of this lamina CBAM. Okay. So CBAMC, you can say CBAMC is a area of the lamina. Okay, how to calculate the area of the lamina? You can see here easily. So you calculate the area of the sector first, OCBA, and subtract these two triangles. When you get the area of the sector minus this triangle CAO, then you are easily going to find out the area of this lamina. Alright. So let's proceed to find out the area of the lamina CBAMC. Okay. So now I am going to erase this one. I will return back to equation number 1 later on. So first we need to find out the area of this triangle. Okay. To find the area of the triangle, so how much is the YMC? How much is YMC here? YMC is equal to 3 meter. Alright. YMC is equal to 3 meter. Half of this 6 meter, YMC is 3 meter. And this is 6 meter. So that's why you can easily find out the theta. The theta is equal to, sine inverse P by H. P means 3, by H means 6. If you do like this, you are going to get theta is equal to 30 degree. Okay, this theta is equal to 30 degree. You get this theta is equal to 30 degree now. And okay, this is a area, not the area of the sector. We need to find out, angle of the sector. So we need to multiply it by 2 to get the angle of the sector here. Okay, this is theta 30 degree and this is also theta. Okay, this is also 30 degree. So add this both to get the area angle of the sector. Okay. So now the angle of the sector is angle COA is how much? 2 into theta, that is 60 degree. Okay, this one is a 60 degree. Let's add up these two to get the angle of a sector. So how much is the angle of the sector? That is 60 degree. So we have got the angle of the sector. Now we need to calculate the area of the sector. So that's why we need this one. So now let's go to find out the area of the sector. Area of the sector. Okay. So we have got the YMC. Let's find out YMO also to find out the area of this triangle. I've got YMC, so that's why I can find out the YMO. YMO is from triangle OCM, you can write like MO is equal to 6 cos 30 degree. Okay, this is 30 degree, so that's why you can write like 6 cos 30 degree. If you do 6 cos 30 degree, you are going to get this MO. Alright, how much is this one? This MO is how much? This MO is 5.196 meter. 5.196 meter. You have got MO. So in knowing the MC and the MO, you can easily find out the area of a triangle. Area of a triangle, the name is CMO. Area of the triangle is equal to half into MC into MO. Alright. So half into MC is how much? MC is 3 meter and MO is how much? 5.196 meter. So that's why you are going to get the area of CMO, that is 7.794 meter square. 7.794 meter square. This is the area of the CMO triangle. Okay. But you need the area of the triangle OCA. The area of the whole triangle OCA, that is 2 times of this area of the triangle CMO. So area of the triangle OCA, or a triangle OCA, that is 2 times of CMO. That is 2 times of area of CMO. That is gonna be 2 into 7.794. That is gonna be how much? Area of OCA, that is OCA, that is 15.588 meter square. 15.588 meter square. Okay, this is the area of OCA. Finally, I have got the area of OCA triangle. So now let's go to find out the area of this arc OCBA. Okay, so area of arc, area of ARC arc OCBA, area of the arc OCBA. So to calculate this one, we need to apply the concept that when the angle is 360 degree, the area is pi r square, and when the angle is 60 degree, the area is that is simply the unitary method. Okay, so let's apply the unitary method to find the area of this arc, circular arc. If the degree is 360 degree, the area is pi r square. You can see r here 6 meter. So when the angle is 60 degree, then it is going to be like pi r square by 360 into 60 pi r square by 6. This is the area of OCBA, that is pi r square by 6. That is going to be, if you put the value of r here, you are going to get the area of OCBA is 18.849. 18.849. If you do this operation, you are going to get the area of sector, that is 18.849, the area of OCBA. Alright. So now let's go to find out the area of lamina CBAMC is a lamina. You need to find out the area of this lamina and go to substitute in the question number 1. So for that I need to subtract from the sector and triangle. Okay, so now let's get the area of the lamina CBAMC. Area of the lamina CBAMC is equal to area of sector. The sector area is OCBA minus area of triangle OCA. Area of triangle OCA. You have got this area of triangle OCA, and let's subtract this from sector and triangle. Okay, so now how much is the area of the sector? The area of sector is 18.849. 18.849 minus area of the triangle OCA is how much? 15.588. 15.588. So you are going to get the area is 3.261 meter square. 3.261 meter square. Okay, you have got the area of the laminar by simple mathematics. Subtract the area of triangle CAO from the area of the arc CBAOC. Okay, so that's why Okay, now let's go to the, substitute this area of this lamina, substitute this area of this lamina to the equation number 1, okay. So in equation number 1, you are going to get the, vertical force, that is gamma into area of this lamina CBAMC into width, okay, that is going to be 9.81 into 3.261 into 1, that is going to be how much? 32 kilonewton, okay. You are going to get the 32 kilonewton of for the vertical force, and from where it is acting, okay. You put a hand over here, is this a liquid in the left side? No. So that's why you can say that it is acting upward, okay. The resultant, we have done this problem by using the resultant concept, extending the extremity toward the surface. So that's why there is no liquid in the left side, so that's why you can say like it is acting upward, okay. It is acting upward. So we have got the horizontal force, vertical force, and let's find out the resultant force and its line of action, okay. So let's write the horizontal force again. How much is the horizontal force in this curved surface? The horizontal force is 176.58 kilonewton, which is acting in this direction, and vertical force is 32 kilonewton, which is acting upward, and the resultant force is how much? So you can find out resultant force by using this formula, F h square plus F b square. So that is going to be 179.46 kilonewton, 179.46 kilonewton, and the alpha line of action alpha is 10 inverse F b by F h. You can do like this. So that is going to be 10.27 degree, okay. This is the line of action you will get, 10.27 degree, and it's, it acts like this, and it is tangent to, it is perpendicular to the tangent of the curve here. It acts like this, and it passes through this O, okay. It passes through this O, and the hydrostatic force, the resultant force acts like this, and it passes through the pivot point O, okay. This is the line of action of the net hydrostatic force acting on the curved surface, okay. I hope you understand up to this point. So I have taken this problem from a book written by Johnny of Douglas, and it is also in Frank M. White book, okay. This is a very important question for the final exam, so keep in touch with my videos, subscribe my channel also. So see you in the next video, okay. Thank you so much.